We're looking at our semester review for pre-calculus. I'm going to make one podcast of the review, and we'll talk about the regular pre-cal and the pre-AP pre-cal test. First of all, number one says know the parent functions, their names, graphs, and equations. Linear, quadratic, cubic, absolute value, exponential, logarithmic, reciprocal, square root, greatest integer, sine, and cosine. So you'll need to go back to that one note card that I gave you toward the beginning of the year, and you'll need to know, you need to review those parent functions. You also are going to need to know the types of function that we just covered over the last chapter. Logarithms, natural logs, and exponentials. Okay, you need to know what their graphs look like, and you need to know what their specific types of transformations look like as well. Number two says find the domain. If you recall, when we discussed finding the domain of functions, we had basically three different types of functions we talked about. We had one type which was just a polynomial function. If you have a polynomial function that's not a fraction or a radical or anything like that, then the domain is always going to be all real numbers. If you have a problem like A or C, you have two fractions, you look at the restrictions on the domain. The restrictions are going to be where the denominator is equal to 0. Because in a fraction we cannot have 0 as the denominator. So you would set each denominator equal to 0, solve for x, and that will tell you what where your domain is restricted or where it does not exist on the domain. Letter B of number 2 is a square root. This is where you take the radicand, the piece that is actually under the radical, this is called the radicand, and you set that greater than or equal to 0, because the radicand can be 0 because the square root of 0 is 0. Okay, so that's basically how you would work those two problems, those three problems rather. If you look at problems for number 3, we have a piecewise function. Remember, a piecewise function is a function in which it's defined over different functions or defined over different parts of the domain. So what we have here is we have f of x is equal to the square root of x minus 2 if the domain x is greater than negative 2. It is 3x plus 1 if x is equal to negative 2. And it is negative 2x minus 2 if x is less than negative 2. So the way this works, if we're trying to find f of negative 3, I have to determine which of the following three pieces do I use. So I have to look at when x is negative 3, well, which one of these does it fall into of these domains? Well, it's where x is less than negative 3, negative 2. Because negative 3 is less than negative 2, you would look at this piece right here for that one. So when you find f of negative 3, you would use this piece, and it would be negative 2 times negative 3 minus 2. And then simplify, and you have f of negative 3. So again, you have to determine which one of those is appropriate to use. For number 4, refer to the graph to the right to answer the following questions. Domain is all the x values, range is all the y values, and then something like, let's say D. Let's look at D. f of 4. What that means is f of 4 means what's y when x is 4. So when x is 4, y is 3. So I'll replace this with a 3 minus f of negative 1. What's y when x is negative 1? Y is 0 when x is negative 1. So minus 0 plus f of 5. When x is 5, y is 2. So I have 3 minus 0 plus 2, which is 5. And that's how those problems work. For f, it says f of x is equal to 1. Well, what's x? F of x equals to 1 means that y is 1. So y is 1 right here when x is right here at this point, which is going to be maybe negative 3.2. And again, y is 1 over here when x is maybe 2.7. And that's how that problem works. Number 5 is the following graph a function why or why not. You use the vertical line test. Number 7 is this function 1 to 1. Use a horizontal line test. And when I write these certain things down, you will need to refer back to your note cards if you forgot what those things were. For number 9, give the equation for the following. Start with the graph of y equals absolute value of x and reflect it in the x-axis, stretch by a factor of 2. It's the same thing. What you want to do is you want to find some values on that absolute value of x, and then you want to do the appropriate transformations. Number 10 says graph the following on a graphing calculator. You would simply put this in y1. Whenever you put a function in that is as complex as the function here, you probably want to graph using zoom 0 so that you'll get a decent look at the graph, and that may or may not be your final graph. You may want to then adjust your window. But you basically want to list all of the intervals for which the function is decreasing or increasing. For instance, if the function looked like this. That's if. This function does not look like this. But let's say we have these values. And maybe our function looked like this. I would say the function is going to be increasing from negative infinity all the way over here to 0. That's where it's increasing. And then it would be decreasing from 0 to infinity. But again, this one is not this problem. You will need to put this problem in y1 of your calculator, graph it, and determine where the function is increasing or decreasing and list those intervals. Number 11, we're looking at composition of functions. I'm going to look at A. We're going to work out letter A. It's very important on subtraction. A lot of people, when we took this test, made a mistake. When we're looking at f minus g of x, we have f of x, which is x squared minus 3x plus 2, and we need to subtract all of g of x. That minus sign must be distributed to every piece of that function being subtracted. If you do not do that, you will have an error. So we have x squared minus 3x plus 2 minus x plus 4. Combine all of my like terms. I have x squared minus 4x plus 6 would be my answer. Again, very important if you're subtracting that you put that last function that you're subtracting in parentheses so that you can distribute that negative sign or the minus sign. These questions for number 12, you simply need to write a story about each of the following bike rides, where D is the distance from school and T is the time in hours since the start of the bike ride. So I'll leave that up to you to be able to come up with a story over those. 13 talks about determine if the functions are even or odd. A function is even if it has y-axis symmetry, and it is odd if it has origin symmetry. Y-axis symmetry is pretty self-explanatory, like C, where y acts like the mirror image here, the mirror, and the left side of the function looks like the right side of the function. So C is an even function. Origin symmetry is when you're looking at the function and it looks the same as it did regularly when you turn it upside down. B is an odd function because of the fact that it has origin symmetry. Suppose P of t is the U.S. population in millions today and t is in years. Match each statement with one of the formulas. I'll look at choice I for this. These are basically all of your transformations. Think transformations. And I'm going to do I because this is the one that is typically gotten wrong. The population 10 years before today. If I'm looking at a number line, such as the x-axis here, if right here is today and I need 10 years ago, then I need to go 10 units to the left here. Which means as far as my transformation terminology, I have choice E, P of t plus 10. Because that gives you the left horizontal shift, and you'll need to apply those same techniques of on 2 through 4 there. 15. The rabbit population on a small island is observed to be given by a function where t equals time in months since observations on the island began. Sketch the graph. Put that in y equals. Zoom 0 will give you a pretty good look at it. Label the axis, identify the minimum and maximum values. I'll leave that up to you. And then answer the following questions with the aid of your calculator. When is the maximum population obtained? That's when you do second trace maximum. For what, D says, for what time interval does the rabbit population exceed 5,000 rabbits? You need to figure out which one represents the population. Is it going to be the independent variable or is it going to be the dependent variable? And find when that value does exceed the 5,000 rabbits. Let's see. 16 says a quartic polynomial has a leading coefficient of -4, a constant term of 3, a cubic term of -6, and the linear term is 7x. Write the polynomial. This is where you need to be able to transfer this verbal expression into an algebraic expression. That should be pretty self-explanatory. Use the rational root theorem to find all the roots. That's where we're going to do some P's and Q's and some synthetic division or remainder theorem, whichever one you choose. Remember, it says find all the roots, not all the possible roots. All the possible roots are the P over Q. P over Q is going to be all of the possible roots. And so we have P is going to be the leading coefficient, which is 1. Q is going to be the final constant here, which is 2. And so we have to look at all the possible combinations of P's and Q's. For instance, if P is 1, let me just skip this part for now. If P is 1, then I have plus or minus 1. If Q is 2, then I have plus or minus 2, and I have plus or minus 1. So then my possibilities for P over Q would be plus or minus half and plus or minus 1, which is going to tell me that I'm going to have some double or possibly some triple roots involved here. I would need to take these values and do my synthetic division or remainder theorem, whichever one you prefer. If I'm testing for 1, remember it works like this. If I'm doing synthetic division, put my positive 1 in here, write my coefficients of my polynomial here. Remember that if you're missing one, like we're missing an x squared term, you must put a 0 there for the placeholder, then the -3 for the x, and then the positive 2. First step is to bring this one down, then I multiply. 1 times 1 is 1, combine -1. 1 times -1 is -1, combine 1. 1 times 1 is 1, combine 1. 1 times 1 is 1, combine -2. 1 times negative 2 is negative 2. Combine 0, that's my remainder. When my remainder is 0, that means that this piece that I did divide by is a root, so one of my roots is going to be 1. What I would probably need to do at this point, especially since I only have 4 possibilities here, a plus and minus half, plus and minus 1, what I would need to do is I would need to check for some possible double or triple roots. The way I do that is I take the remaining part here and do my synthetic division again with 1, checking for the possibility of a double root. Find the equation of the polynomial graph. This is where you have a single root at negative 1, a single root at a single root at negative 2, a single at negative 1, a double at 1 because it bounces, and a single at 3. So far I have x plus 2, x plus 1, x minus 1 squared because that's the double because of the bounce, and an x minus 3. I can also find the leading coefficient because I'm given the point 2 comma negative 1. The way I do that is I write this in this fashion: y equals a times all this stuff, and a is my leading coefficient. I plug in x, which is 2 for x, y, which is negative 1 for y, solve for a, and when you do that you will get the following answer: y equals positive 1 over 12 is what a becomes, and then x plus 2, x plus 1, x minus 2 squared, x minus 1 squared. And then x minus 3, and that would be my answer.